Warm welcome to join the SciFinder N presentation. I'm here with my colleague Tetiana Khristova, and my name is Veli-Pekka Hyttinen. And our topic of today is the news from Chemical Labs as Service, a new CAS solutions, which includes SciFinder N and representancies tool, as well as we have we would like to show you the new formulas content, which is the formulations. Chemical Labs as Service is a part of American Chemical Society, a subdivision, and we are based in Columbus, Ohio, where we have about 1,500 people, and we have editorial scientists who index the content from journals, from patents all over the world. Every day we index about more than 15,000 chemical substances, give a CAS number, and 75% of these substances come from patent documents. So that's why patents are very important. And we cover 63 patent offices, so it means that we also, our tool is used at the patent offices. We use all kind of index terms. CA lexicon covers 100,000 index terms. We index reactions, nowadays also methods. We give a new number for scientific method, as well as we index formulations. Marcos indexing is related to it's related to the structures, open structures in patent documents, as well as when we index the content from patent documents, we pinpoint the location of these substances. And that's very important because it covers all languages and structures and all different names, name variations, names in Chinese, Japanese, Korean. All these are indexed in the same way. Very intellectual, very time-saving feature. My background as a patent professional, I can tell you that this is a tool really which helps professionals, patent professionals even, but also any scientist to locate the important information. SciFinder is a blueprint of chemistry, and this information is showing that how much the information is linked between each other. It means the present situation looks like a neural network. So information has increased potentially, exponentially, and that's what we have had to build a new system like SciFinder N to be able to handle all information and of course all these different features which our customers would like to have. Okay, this I don't know why this one looks a little bit difficult, but I just jumped to the slide where I have summarized, listed the new features and new content of SciFinder N compared to the current classic SciFinder version. For instance, there is we have the references, 50 million references from CA Plus database, 25 million from Medline. These two combined in the system, 220 million substances includes also the biosequences. They all have CAS number, what we actually give as an authority. 118 million reactions, and nowadays also the supplier data can be also searched on SciFinder N. If we look at the quite a simple search screen, it shows the way of searching easily this. SciFinder N covers 3 petabytes of data, and that means that if you would watch a film which is stored in HD quality, it would take 40 years to watch the film. So that's much index data we cover from over 200 years today. New content is 5 million analytical and synthetic method protocols. That is the methods now content. Then we have a patent pack which covers more than 10 million intellectually indexed patent documents, and the representatives planner, which is a newest tool as a part of SciFinder N. And if we look at the new features, there is automatic search history, auto-suggest, Boolean operators, citation map, combine text and structure search, as well as you can run multiple searches simultaneously. The new world-class relevance ranking is something which we are also have been developed, and there is artificial intelligence working behind, so the best, the most relevant answers come up front first. When you search SciFinder with an asterisk, it actually uses the left and right hand truncation. That means that the system looks for, like if you search substance names, and if you type something like, you can even type this asterisk inside in the word, the system looks for the different options, and for instance brings all these results. If it's keywords, if it's substance names, or organizations, etc., author names. Power after asterisk here would bring 9 million benzene compounds, substances, which has a benzene as anywhere in the name. And that all you can really view as in new SciFinder, and there are no limits in the size of. And what is nice as well, it opens up this autosuggest, which shows up the different names. There are keyword search combined with structures, very powerful way of looking at. Here we have as example, the next one, for instance, is cancer therapy asterisk and targeted nanotechnology. And that is combined with the structure. It brings patents, for instance, from all over the world. And if that one is, let's say, any language, it will still show us there are 1,400 substances and 3,000 reactions, which are all indexed, because the CAS numbers are related to these substances. And when the substance exists in the system by any means, name or structure, usually, of course, in reactions and synthesis, that is structure. So that is indexed there. And that's really a very convenient, nice way to locate where this relevant information is there. This example shows up how powerful patent back can be, even the document is Japanese language. You see, this is the structure on page 143. There are 369 pages total in this long patent document, and this is the name of the substance in Japanese language, so that all can be retrieved. Very nice, very smart system. Then structure searches. When you run a structure search, it automatically runs 3 different types of searches at the same time. So exact structure, substructure, and similarity search are run, as you see here on the left-hand side. And that really is a very nice way to quickly see if you need to go to substructures, if there is enough exact structures for your interest, or if it depends on your way of filtering the answers. Marker structures in patent documents can be also searched in a very nice way, because the very first time the results are actually shown as a marker structure in the document. If we see here, there is a marker structure, and the corresponding marker structure in the patent document has been indexed, and that is on page 286. So that also saves a lot of time if you should go through all the pages, hundreds and hundreds of pages yourself, the manual work. Honestly saying, by my experience of looking at like 10 patent documents, which all cover more than 1,000 pages, it have taken usually many days to go through, 3-4 days to go through these page by page and make like notes by hand. The same work today with patent back can be done in 10-15 minutes. And reactions can be also searched in a very, very powerful way. And the way we now put the reaction results are put in the schemes, which also is more helpful to locate the relevant information. Here we have the experimental protocol, so that is the recipe for the synthesis. And here we have that recipe available, which we have about 4.5 million of the synthetic preparation synthesis. And we also cover analytical methods, which are in a separate database, methods now database, and that is there as well. It's 500,000, which you can actually analyze by analyze metrics, method category, and technology. Chem is a central plus is historical 3 million German abstract. We have indexed the substances from them, that collection since 1830s. SciFinder and retrosynthesis planner is a new way of looking at backwards. If you have a target molecule, you want to see how it was synthesized. You go retrospectively backwards, and there is a computer-assisted synthetic design software, which is also kind of artificial intelligence, which works behind the system. You can look for or check the synthesized intermediates. You can update the production of syntheses with the latest developments, even evaluating the different synthetic options, and especially if you look the information from patents to, for instance, to look if that gives you the freedom to operate. And here we have it shows up the estimated yield and price. Also, there is evidence of this from literature available in the retrosynthesis results, and also the steps. You can see the different alternative steps and go and choose, for instance, if that looks better, and gives that option for you to use the tool. Formulations is the latest database, which has been introduced a month ago, and the formulations, there are millions of formulations which are indexed, which have been indexed by our editorial scientists, same way as we index all other content as well. But now we have looked for the formulations related to pharmaceuticals for cosmetics, especially cosmetics and agrochemicals. And there is, you can see the details of the formulations, their purpose, where the documents are. We cover patents, journals, and especially the product inserts, and that information is indexed from there. So how this formulation actually is related to, for instance, chewable tablets or microcapsules, or the way pharmaceutical ingredients are put together as these compounds, as well as we have the first time all regulatory information in one place. There are the FDA, Orange Book, and other indexed content from the regulatory data in one place in formulas. And as well as there are common flow examples available, quantity, also for the ordering and shipping information, where you can find these substances. And this is a picture of Finland in midsummer when there are white nights. But I give the floor for my dear colleague Tetiana to take over and to go for a practical examples to show how SciFinder N works very nice and powerful way. And if you have any questions, you are welcome to present. I think so we need to now do some changes.
It works.
Okay, so excellent.
Okay, hello everyone. So I'm going to show you a few examples, thank you, in SciFinder as well as formulas. So if you have any questions, please don't hesitate to interrupt me. So as you see, this is how the, so I'm wondering, okay, there is, okay. So this is how the, how SciFinder N looks like. So as you see, it's very user-friendly, very clean interface. So you can easily identify that, for example, there is a substance search, reaction search, references, and the suppliers. And you can combine. So today we're going to check the usual reference search, as well as combination of the structure and reference search. We will also look at the reactions and the retrosynthesis. So let's start from the simple reference search. So what is also interesting here, before I went to the examples, let me go a bit down. So when you do a search, as soon as you did a search, the system automatically will save your search, and you can, anytime, you can rerun it. So as you see here, there is a button, rerun button here, I think. Yeah. So you can do any search, you can rerun any of your search. So let's go up. So I prepared an example that relates to mitogen protein. So as you remember, Velu told you that there is a auto-suggest, so you can see it in action. I think I made a mistake. So I'll take mitogen activated protein. You see that the system tells me that there are some other possibilities. So I'm clicking on search. And what is also available, I'm not sure if I mentioned, there is a relevance ranking inside SciFinder N. So you can see that the most important publications are on top. So here's the relevance ranking, so the best, the good, and the fair. So usually we would take the good and the best, and also you can see the highlighting. So this is what the system found for me and highlighted in the text. So you can see so that there is a filtering. So let me go down a bit. No. This way. Okay, so there is a publication here you can check. You can check as well. So if, for example, you want to collaborate with someone, some organization on this topic, you can easily go to the organizations and have a look who is working. Maybe it's your colleagues from the other city as well, or from the other country. So it can be a company, it can be university, doesn't matter. And what is the most important here as well? So this is the concepts. So as you might know, all our information is indexed by scientists like you, and they have each our publication. Let me open one of them. Will have a number of so-called concepts or keywords, but not those keywords that you as an author gives. It's our standardized vocabulary, which helps you to filter out your answers. So here they are. So you can see, for example, when I find an article or a patent, let's say in the text itself, they can probably not even mention protein sequences or pancreas. But if they are talking about it, our scientists will add this as a concept. So this way you are sure that this is the publication you need. And as well, as you can see, I opened a new tab. That means that in SciFinder N, you can work in parallel. So several searches, several windows, and nothing is lost. So I'm going back. And so this is a simple search. And as well, there is a formulation field here. So you remember Velu told you about formulas. So we have a separate tool that is called Formulas. So it's a database with formulations. But we also have a connection of it with in SciFinder N. So you can easily identify those publications which contain formulations, for example, related to anti-tumor agents or, let's say, drug delivery system. So just clicking by that here, and let me show you what I mean. So you see this is a patent, and I will go here. So open it in a new tab. And if I go down, so you can see we have a field formulations, and here is the formulation itself. So if I click here, I will open the tool itself, the formulas tool. If there is anyone working with formulas, with formulations from you? No? Nobody works with formulations? Okay. So let's go back to the home page. So I'll, in order not to lose this kind of search, I will just open a new tab. And now I want to show you a combination of the reference of the topic and the structure. So I'll take the same protein, mitogen activated protein, and we'll take a course structure. Yes. Okay. So I'll draw some course structure that I'm interested in. Okay. So I need to add some nitrogens here. And this is the, okay. And the double bond here. And okay. So in this way, my SciFinder N will search only those publications that contain that structure or a substructure of that course structure. This is why, if I go down a bit, you will see a substance role. If you remember, in just a simple reference search, there was no substance role because there was no connection with the structures. But in this case, I can, for example, select only those publications that relate that there was some biological study related to that structure. So in this case, since I used a core structure, most probably I would be interested in substructure, not the exact match. And everything else is more or less the same. So let's just also look at the patents. I see a nice patent here. So we have a patent pack tool, in Velu mentioned that. So if I click, let's open just the publication, the patent itself, just to show you the record. So you see the families, the patent family here, down. Okay, so you can see the patent family here. And I don't see the PDF. Okay, it's a bit doesn't work for that kind of search I wanted to show you. I wanted to show you the location of the substances. Let me have a look. Okay, maybe we can go. Let's select just the patents. I'll just select the patents. So you can select also the type of the document. So if you're interested specifically in the patents or articles, you can select those ones. And let's have a look. Yeah, so if you click on the viewer, you will see so the patent itself and the location. So for example, let's take this structure, a bit down, a bit up, and there is a few locations. What? Okay, a bit bigger. Okay. I don't think I can make it. Not sure what you mean. Okay, so if I click on the page, SciFinder N will show me the location, the exact location of the structure. So you see 2-amino-6 hydroxy 7-ida, and etc. So it doesn't matter if that was a drawing structure, if that was a text or a structure number 1. So everything will be located, because this is what our scientists do. Okay. And you can have also the PDF plus. So what that means, so if I click on there, I will get the PDF. So now it's a searchable text. So if there is I want to make it bigger. So if you, as you might know, the patents usually are scanned, so it's hard to work with them. Now you can work already with the text. And at the end of the patent, our scientists added a table with the location of the structures so that you can work offline with that patent. Here it is. So the patent, the page number, the CAS register number, the name, and the structure itself. So this way you can work with the patent. Okay, so that was combination. And now I want to show you in structure search, and we will go to the reactions and to the retrosynthesis itself. So as you see, so I did my search, and I can rerun it again because it's automatically recorded here. So this is the rerun button. So I'll took as an example a substance called idalalicip. Okay. As you see, the auto-suggest comes here, and here's my structure. So I can just pick it up from the list and click on search. So I found my structure here, how it looks like. I can click to view it bigger one. And as you see here, there is reactions, and there is a retrosynthesis plan. Let's have a look first to the reactions. I'll open a new page. And as you can see, even the first scheme, so there is this scheme 1, but there are 6 reactions behind because they are all combined by similarity. So only, for example, the reagent or catalyst might be different, but the reactant and the product is the same. So in this case, what I also want to show you is our database that's called methods now. So we'll select, so we have experimental protocols inside SciFinder N. So I want to show you how that looks like. And let's take a 5-step reaction, so I can filter out by the steps, of course, and some other. Okay, and if I go a bit down, I can see the experimental protocol, click on it. And we will see, so for example, this is the last step and the other steps. And okay, accidentally click on the structure itself. If I go down, I can see the step 1, step 2. Let's say step 2 is interesting for me. And you can see the reagents. And you can see what kind of reactants, what kind of solvents, and the most important is the step-by-step procedure. So let me go down. Okay, so here it is. And the scale, of course. And I think there will be a spectrum as well. Here it is. Okay. And the same I will see for the other steps. And I can download it and work offline in the lab, for example, if I need that. And we can go back to our structure. And let's play now with the retrosynthesis. So I will click on Create Retrosynthesis Plan. Let's say those reactions that I found doesn't work for some reason for me. Either they are too expensive, or maybe the yield is too low, or some other reason. So I can then, in this case, go and generate retrosynthesis route. And this is how it looks like. So I'll make it a bit smaller. So, so this is the overall yield will be 61%. If I go to the steps, I can see, for example, the first reaction, the last step actually. So there is 2 evidence. So that means that there are 2 publications from which we extracted those reactions, those single-step reactions for that specific step. And there is 13 alternative steps. That means, let's say, I don't like that step, maybe for because of the yield, or I don't know, because of the starting materials, of some other reasons. So I'm clicking here, and I can change it and select other step that works better for me for some reason. And let's, for example, say this one, or maybe even go a bit down. Let's say this one. There is free evidence, a bit bigger than this one. If I click select, the system will rebuild the synthetical route, and you will see the new retrosynthesis plan. As you see, it's different. It is much different. It's very different from the one that we saw in the beginning. And we can see also the yield next to each step. We also have information next to the compounds about the supplier. So if I click here, let me open a new tab. I will see the supplier list that can provide me, make me that substance. So you can see the information about the substance name. You can order them from the supplier, some purity information. You can filter out the supplier list by country and by purity, quantity, etc. So that's available. What else? Yeah, I think that's more or less what I wanted to show in SciFinder N. So I'm thinking that we probably shouldn't go with formulas if they are not working with formulations.
Well, perhaps not.
Yeah.
You can show the indication as well as
what do you mean by indication?
I mean, you already showed how the formulations are
right.
also shown in SciFinder N.
Mm-hmm.
You don't have access to the formulas database, but you can see the evidence from the SciFinder N that there is formulation, pharmaceutical formulation, or agrochemical. For instance, in the SciFinder N actually contains the information where there is about the formulation data, formulation information. Let's say that if you take something like to show up, and on the left-hand side there is how you filter the answers in SciFinder N, and there's also one field which is formulations field, and it shows if there are pharmaceutical or agrochemical or cosmetics related formulations available for that substance. And in this way, as you know, that we live in the world of formulations, toothpaste, shampoo, medications, tablets, different kind of, let's say, especially new generation medicines, personal medicine, that involves a lot of interesting formulation. Purpose is the field called, and if you open up the view launcher, the annual or the formulation purpose, okay. Any field you see, you can open up and even search in the fields, index terms or formulation purpose field or organizations or inventors, authors, all these you can open in a new window where you can like even search or look the top account or alphanumeric order or the search find like anti-asthmatic or something like
sure
that.
If I type it right,
yes,
is it?
Hopefully.
I think there is a mistake. But...
So if that is correctly,
okay, yeah, it is correct.
Okay, there was some. So if you think about, you have 50,000 answers and you want to focus on like anti-asthmatic or asthmatic, and you use this one. So this is particularly very, very helpful and very useful because we have already indexed for you our 1,000 editorial scientists who index daily basis, like about 5,000 new references all over the world and about 15 up to 20,000 new substances in daily basis are added to the system. So that all is there, and 200 years of this coverage as well. Perhaps you also show how this my organization, available in my organization field as well.
Okay.
If you close this one and go back, available at my institution. That is actually quite nice as well. It depends on, especially in universities, you have access to electronic journals, full texts, and perhaps you have also indexed what you have in paper copies or available in the library. And that's also is there because it looks at your firewall where the information is that you are accessing to, and if you update that information in the SciFinder content that usually done by libraries, you can see what you have available. And this is also very helpful because it's straight away you can see, okay, we have access to these 700 or how many, 704 digital full texts. So, and then I could perhaps filter my answers accordingly. And then perhaps there are some others I don't have, then it comes later on. And also, for instance, if you open this view launcher, the year's annual up there, so that is also nice. It gives the look at that 1830s is the starting point, because Tetiana also have access to ChemZend information, but we actually have SciFinder covers the oldest references are from 1770s in there, and depending on, of course, where the oldest references are from, but different publications. So if we look at that, how many different publications we have indexed, it's more than 50,000 different publications in 200 years. We actively index now 10,000 journals and patents from 63 countries, but we have done it over 200 years, over 50,000 different publications, journals in history. So that's a huge amount of information. Do you have any questions? Anything would like to hear more? Perhaps you show once more about how this autosuggest works. Okay. If you type like benzene or whatever the substance name. So now you see how this system opens up the succession for autosuggest for all substance names from the index. And if you add benzene and asterisk, now what happened, it looks left and right hand truncation automatically. And if you click enter or this magnifier, so it will bring us more than 9 million substances where benzene is. And if we go to show up the filtering options, substance class, for instance, number of components, substance class, this is directly, if we would be interested in polymers, for instance, we would take out from 150,000 polymers and ignore the other almost 9 million substances. But this is the way you filter the answers. There are no limits of the answer sets. The current classic version is 20,000 answers. If you have more, you have to refine your answer. But here you just can filter. And perhaps if you go a little bit lower, here you will see as well experimental property and experimental spectra. This information is there straight away. So now you don't need to click 13, 14 times to see this information, but it's there. And you can filter out that I'm interested in those benzene substances which has benzene anywhere in the name and has like proton NMR spectras available. That would be 40,000 substances. So in this way, you can focus on like evidenced substances which has experimental property data or spectral data available.
Thanks. So any questions? No. So what do you use currently now in your organizations? Do you use some tools in your organization, universities or institutes?
But now our institution don't have
subscription.
Yes, to SciFinder.
Mm-hmm. Okay.
For us, it's very interesting, but for the moment, we can use SciFinder.
We would like to have a free trial to see how it works for
Mm-hmm. Okay, thank you.
Thanks.
Unless there are no more questions, so we are happy we have our booth, as you see, downstairs, so please welcome to there. And thank you very much for your attention. Thank you, Tetiana. Mulțumesc.